Assalamu alaikum wa rahmatullahi wa barakatuhu. Welcome to Haseeb Electronics. Friends, in this video I am going to share a very useful technique to troubleshoot a LED lamp. There are LEDs, light emitting diodes, and there is our small circuit. We will see in detail. We can see it have a very dim light. It is not bright. I applied voltage. This time I made my room dark to show you this lamp. It is not working. How we can test it, how we can troubleshoot it, we will see in detail in this video. If you are new to my channel, after watching this video, if this video is good for you, there is some useful material for you, you can subscribe. First of all, I am going to heat up using hot air gun this corner, which is connected to plastic, and this transparent glass. Carefully use a sharp knife or a sharp screwdriver. Sometimes it is connected with a glue adhesive, or sometimes it is by punch fitting, by press fitting. So you can use a heat gun. It is very useful. First of all, we will open this. Carefully open this. Now I opened it. You can see there is some glue or silicone type material which is adhesive. Remove it. Now carefully remove the circuit from the body like this. Now I applied voltage in the dark room. We can see the LEDs are not too much bright. They are not producing sufficient light. We will see what is the reason why the all LEDs are not illuminate. It should be illuminate. It should be give a good light. We can see there are two pieces. One is LED lamp panel and the second is power supply. There is a inverter circuit inside this switch part power supply that there is. This is LED panel. There are series LED. How we can test? First of all, I will demonstrate cold testing without voltage, and the next step I will apply power and I will show you how to demonstrate, how to troubleshoot. First of all, connect to check multimeter. I set it to continuity diode mode, and I apply to the LEDs. If LED is not glowing, you can reverse the leads. Here this LED is glowing. All LEDs we will check one by one. If any one LED is not showing something, you have to reverse the leads. As I reverse the leads, we can see, we can check one by one, because these LEDs are in pairs, not in pairs, in series. Some set, we can see this LED is most brightness, so it is not good. Every LED should give equal brightness. Any LED that is not working, we will make a marking. We can see this is illuminant. It is giving illumination. It is bright. This one is not working. I marked it up. We will check it. We will check one by one. Actually, what happens? This power supply circuit takes 230 volt, 220 volt from our line voltage. Now I will separate this holder connector. Carefully using a sharp knife, we will remove this. There are two wires. One wire is connected to input terminal with a fuse resistor. This is fuse resistor. I will demonstrate how to test this fuse resistor. Sometime due to over voltage, this fuse resistor is burnout. You have to replace just a very low price. We can see it is 5 ohm fuse resistor. Sometime 5 ohm, sometime it is 10 ohm. This is 5 ohm. Then there is a circuit. This circuit is very simple circuit. It takes 230 volt, then it converts into DC voltage with a bridge rectifier, and after that there is a switch mode circuit, inverter circuit. After that a rectifier. It takes 230 volt, and then it makes a DC voltage, that is isolated voltage. To apply this circuit, I will connect these heat shrink sleeves to the crocodile to make insulation. I have a complete jig for circuits, but now to make it easy for everyone, I will demonstrate. Now I will connect power. Before this, that was a cold testing procedure. Now it is called warm testing. Live testing. I will apply voltage and we will check it in detail. Carefully, when you are working on an electrical circuit, electrical live circuit, when there is a line voltage, you have to take care, special care, because it is sometimes becomes very dangerous. Safety must be observed every time. You have to observe safety. Now I connected a voltage to the line socket. We will connect this circuit to the line voltage, and now I will demonstrate how you can find where is the problem. First of all, you have to find the problem. I will show you. Set AC voltage and check it at input terminal. It is 231 volts. After that, there is a DC stage, a rectifier at a capacitor. At capacitor, it should 333 volt. After rectification, on the capacitor you will find 300 plus volt. And at the output open load, it is 155 volt. When we will connect LED terminal, it will drop down to 80 volt or 100 volt, like that. First I remove the marked LED which was not working. I connected it to power supply circuit and I make a jumper to demonstrate, because it is in series. These LEDs are connected in series circuit. We can see some LEDs are working, and now there is an other LED which is red marked. We have to remove that one also, and we will check voltage now. First of all, I will demonstrate how you can check. Connect to DC voltage and check voltage. We can see 1.5 volt, 1.54 volt. When there is open circuit in series, the open circuit takes or drops maximum voltage due to infinity resistance. It is 100 volts. So every LED must take equal voltage. This LED, which one taking 100 volt, I removed it by the cutter. We should use hot air gun, but I am using to demonstration. Now I removed it and I applied a jumper. I will apply a jumper. I removed just the upper plastic. I did not remove from the circuit. It is just to demonstrate. After that I will replace these LEDs and we will reassemble it to a serviceable condition. Now I bypassed, I made a jumper for the bad LED, for the unserviceable LED. We can see it is a bright. It is now functional, but we have to remove this jumper. I will remove this jumper and I will remove the contact contact of the LED so that we can install a new LED. It is very cheaper. You can find about 20 or 25 or more than this LEDs in $1. So it is very cheaper. If you can repair LED lamps, it's very useful. It's a very useful technique. So because it is divided in portions, this portion, one portion we have cleared because it is in series parallel circuit. We can see this LED, it is 7.5 volt, this LED 7.4 volt, 7.5, 7.2, 7.4, 7.2. Oh, this LED taking 96 volt. So this LED is bad. Any LED taking more voltage drop is extra, we have to remove that one. This LED, we can see all LEDs are taking 7 volt. So this LED is dropping the voltage for the other LEDs. So we have to remove this one because this is taking 98 volt. All LEDs should drop equal voltage in the series circuit. So this voltage, these are abnormal voltage. This voltage must be equal to the every LED, so all LEDs can function. We will have to remove this LED. I will remove power, and this LED we are already marked it because it was not giving a good continuity in cold testing. Now I will make a jumper. Just I have to remove the insulation, the metal plastic part of the LED, and now we will connect it. We will bypass it, the two terminals of the LED as a jumper circuit. So I jumpered it, I bypassed this LED. We should not bypass. I will remove these 3 LEDs because this circuit is not working properly. So any bad LED, we will remove that. Oh wow, it is working. It's working. That's good. So friends, I discussed 2 methods to repair this LED panel. How? The first method, that is cold testing. You have to test using continuity or diode mode. And the second method, apply voltage and measure voltage across every LED, individual LED. It must be equal in the circuit. If any one LED is taking more voltage, that means that LED is not good. You have to remove that one and you have to replace that. I will replace this LED and the other 2 LEDs. You can see these 3 LEDs I will replace now. I will purchase new LEDs. So maybe we can see every LED, it is very cheap with respect to the complete LED lamp. Now I will discuss how it works. First of all, it takes 220 volt or 110 volt, which one is line voltage available in your country. After that, there is a power supply circuit. I will discuss in detail. There is another very detailed video for switching mode power supply, how a switching mode power supply works. Now I am making a block diagram. The first block, that is a power supply circuit, and there is LED circuit, LED series panel. These LEDs we were testing in cold testing and warm testing. These all are connected in series. If anyone, I have already uploaded a video what is series circuit, what is a parallel circuit. We can discuss, we can understand from that video. I will give link in the description. So in any series circuit, if any one component is fail, all the circuit will dead, all the circuit will stop functioning. How is working this circuit? First of all, takes 220 volt. Then there is a bridge rectifier. Sorry, it was defocusing of camera. So it is taking 220 volt. Then there is a capacitor after bridge rectifier that takes gives us 330 volt. Then there is inverter circuit, that's called SMPS, switch mode power supply circuit. We can see here we receive 230 volts. After that there is a capacitor. This capacitor normally marked as a 400 volt. Then there is inverter circuit. What is inverter circuit? One is there is a IC and transformer, and after transformer there is a rectifier circuit and one capacitor for removal of ripples, this rectifier circuit. After rectification, DC voltage. Here is 100 volt approximately with load, 100 to 120 volt with load. And if you will test while removing a panel, LED panel, you will find 150 volt, 160 volt. So now I will apply power, and it is working, and we will measure voltage. You can check it now. I will demonstrate now AC voltage, the input voltage. Here is input voltage. It's about 230 volt, 232, and then we will switch to DC voltage and we will check the output of the bridge circuit. If you cannot find voltage here 330 volts, then the bridge circuit or the capacitor is bad, you have to replace that one. If the input is not available, then you have to check the fuse. Now we will check the output of the circuit. It should be about 100, around 110, 120 volt. As I told, 80 volt to 120 volt, so it's working. Here is 100 to 120 volt normally, because I removed 3 LEDs, so there is an excessive voltage drop due to decrease of resistance. These voltage are feed here. Friends, how did you find this video? If this video is useful for you, good for you, you can like, subscribe, share, and hit the bell icon button for my future videos. These LEDs are in series. If any one LED, suppose this LED is not working, you have to check the voltage across this LED. If it is giving a full voltage or approximately full voltage, that means this LED is open circuit, because when there is an open circuit or malfunctioning, it drops maximum voltage. This circuit works like this, so you have to replace this LED. Thank you for watching. Every LED must be drop same voltage. It should show a maximum equal voltage. If there is abnormal change in a series circuit, that means you have to replace the component. If you are new to my channel, subscribe, and thank you for watching. Allah Hafiz. Assalamu alaikum wa rahmatullahi wa barakatuh.